This video is about finding the intersection points between circles and straight lines. So this question is asking to sketch the graph of the two objects, a circle and a straight line, and find the exact intersection point. So you're going to expect that there's some surds involved. So the process for this is, I've taken the liberty of drawing these already. So the process of this is exactly the same as finding a parabola and a line. So we have two equations, and we sub in y equals 2x into x squared plus y squared equals 4. Okay, so the next step here is to sub it in. So x squared plus now y squared we know is 2x. Okay, so that fits into here. Now we have to remember that all of y is squared is equal to 4. Okay, so now we have one variable we can solve for that variable. Let's work through this. X squared plus, now if you remember our index rules, 2 to the power of 2 is 4, x to the power of 2 is 2 equals 4. Group together like terms, we've actually got 5x squareds here equals 4, and we have, we're going to divide by 5 to get rid of that 5. X squared equals 5, and we square root to get, okay, now remember when we square root, we get the positive and the negative versions of both of that. Okay, so what that means is in this graph here, this being the x-axis and this being the y-axis, we know that the intersection point is going to be here and here. Okay, and what you should see is that this is a positive value of x and this is a negative value of x. Okay, so this will be positive square root of 4 actually. Let me just finish this. It's not actually in its most simple form because the square root of 4 is actually 2. Okay, so 2 over square root of 5, if you remember your surds. Okay, so this will be the positive 2 over square root of 5, and this will be the negative 2 over square root of 5. Okay, so that's where these points are. Now to find the y versions of that, okay, let's give myself a little bit of room over here. We sub in these two values. Okay, now just if you take a good look at this circle, because it's consistent around the origin. Okay, the y value here is going to equal the y value here, but it's just going to be negative. Okay, so just to make things easier for ourselves, if you find one, you've got the other. Okay, so I'll just draw a little line there and a little line there. Okay, so let's sub in x equals, and we'll do the positive version of this because it's the easiest. In fact, if you square it, it just becomes the same thing anyway. So x equals, so let's do that. X, so 2 over root 5 all squared plus y squared equals 4. Okay, so now we solve for y. Okay, so 2 squared is 4. And let's remember the square root of 5 all squared. We'll come to that in a minute. Okay, so 4 over, now the square root of 5 all squared, you should remember, is 5. Okay, that equals 4. Okay, so now let's solve for y. We've got to take away 4/5 on both sides. Okay, so y squared equals 4 minus 4/5 is 3 1/5. Okay, let's make that into a improper fraction. So 3 times 5 is 15. 15 plus 1 is 16 over 5. Again, let's square root the whole thing. And again, the square root of 16 becomes 4 over the square root of 5. Okay, so obviously when we do that, we're going to get the positive and negative of both of those, as we said before. So that is the, let's say the top one is the positive version, 4 over root 5. So that'll be 4 over root 5, and this will be negative 4 over root 5. Okay, so the coordinates pairs are going to be this, and the negative version down the bottom there. Okay, so that is how you find the intersection of points and circles. It's similar to the parabolas. Yeah, so good luck.